esterification reactions are a reaction that will condense out a water. So it's a dehydration reaction. It's removing, it removes a hydroxide and a hydrogen. The hydroxide comes from the carboxylic acid, and the hydrogen comes from ethanol, or the alcohol. And so you get the H2O is coming from this green part here. And what happens is you get CH3, CH2, CH2, C. Now this structure is a C double bond OH, and this is an HOCH2CH3. So I'll just draw it out because it kind of makes it a little bit easier to see what's going on. So what happens is this hydroxyl from the carboxylic acid and the hydrogen condense out to make this water. And then this carbon has a double bond. So this is a carbonyl bonded to this oxygen, bonded to CH2, CH3. So this is a fine way to draw this. If I wanted to condense it down, it'd be CH3, CH2, 2C double bond O, O, CH2, CH3. But for naming purposes, it's actually easier to turn it around. So the alcohol is considered like the branch part of the name. So this is going to be an ethyl from this. This part is what contributes the ethyl. And then the 1, 2, 3, 4 is the butanoate. So this part comes from the carboxylic acid, and this part comes from the alcohol. So it's actually easier if you draw it the opposite way, where you, for naming purposes, this follows the name, ethyl butanoate. But if you can identify where the carboxylic acid part is, then you can name this because the other part is the alcohol. So here I've got a methanol and 1, 2, 3 propanoic acid, right? So this is propanoic acid, and this is methanol. So I already know that this is going to be called methyl propanoate because I know what the reactants were. This gives me my branch, and this gives me my parent chain O8. So this is going to give me, I'm going to draw it methyl. So my methyl is here, and this hydrogen is gone, and then this will be gone. So then it's bonded to this carbon, double bond O, CH2, CH3, and these things contribute to make my water. Okay? And if they gave you some structure, as long as you can identify where the alcohol is, then the carboxylic acid part always has the carbonyl in it. And sometimes you'll see a structure written like this, CH3, CH2, O, O, C, CH2, CH2, CH3. Well, these are hard ones to read. But if you look, this has got a carbon with 2 hydrogens. This is the single bond. So this is the alcohol. That's the ethanol part. And then this has got a carbon that has got a double bond in it. So this is from your carboxylic acid. This came from 1, 2, 3, 4. This is butanoic acid was where this came from. So this will be ethyl butanoate. Okay, and the trick is this part. You see this? This has to have the double bond on the carbon, and that's part of this chain.